This isn't just a galaxy, it's a violent trillion-star monster hiding in plain sight, and it's hurtling right towards us. For a decade, scientists pointed the Hubble Space Telescope at our galactic neighbor Andromeda, piecing together the largest, most detailed portrait of another galaxy ever created. What they found wasn't a serene spiral, but a battlefield of cosmic collisions with a turbulent past and a shocking future that involves us directly. Let's explore this incredible story together. 1,000 years of discovery. How do you even begin to map a galaxy 2.5 million light-years away? For most of human history, it was impossible. It all started with a simple glance. In 964 AD, the Persian astronomer Abd al-Rahman al-Sufi looked up and noted a nebulous smear in his star charts, the first known record of Andromeda. For centuries, that's all it remained. It took another 650 years before anyone got a closer look, when in 1612, German astronomer Simon Marius aimed a primitive telescope at it, but the first true revelation of its structure came in the 1840s. Using a colossal 72-inch telescope named the Leviathan of Parsonstown, the Irish nobleman William Parsons, the 3rd Earl of Ross, became the first person to resolve the spiral structure in a nebula. This telescope was a true engineering marvel of its time, and its immense light-gathering power revealed what no human eye had ever seen. This discovery ignited the astronomical community, inspiring the first-ever photograph of Andromeda in 1888 by amateur astronomer Isaac Roberts. His image, which required a difficult multi-hour exposure on a fragile glass plate, clearly showed its magnificent spiral arms. A fuzzy patch in the sky was slowly revealing itself to be something far grander and more complex than anyone had ever conceived. The Great Debate. So, what exactly was this majestic spiral? For decades, that question sparked one of the most intense arguments in the history of science, known as the Great Debate. In 1920, two prominent astronomers, Harlow Shapley and Heber Curtis, went head-to-head at the Smithsonian Museum of Natural History. Shapley, a brilliant and forceful personality, argued that our Milky Way galaxy constituted the entire universe. His evidence was his recent work on globular clusters, which showed the Milky Way was vastly larger than previously thought. He believed these spiral nebulae were simply gas clouds swirling within its boundaries. On the other side, Heber Curtis argued for a much grander cosmos. He championed the radical idea that these were distant island universes. Curtis pointed to the greater number of novae, exploding stars, in Andromeda compared to the rest of the Milky Way, calculating they must be incredibly distant to appear so faint. He also noted the presence of dark dust lanes in Andromeda that looked strikingly similar to those in our own galaxy. This wasn't a minor academic disagreement, it was a fundamental clash over the scale of existence itself, a debate that defined an entire era of astronomy while awaiting a definitive answer. Hubble's revolutionary finding. Then came the man who would provide that evidence and forever change our place in the cosmos. In 1925, astronomer Edwin Hubble used the towering 100-inch Hooker telescope at Mount Wilson Observatory to deliver the final word. His masterstroke was identifying specific pulsating stars within Andromeda called Cepheid variables. These stars are incredible cosmic yardsticks, thanks to the foundational work of astronomer Henrietta Swan Leavitt at the Harvard College Observatory. Leavitt had discovered the period-luminosity relationship. A Cepheid's pulsation period is directly linked to its true intrinsic brightness. Hubble meticulously measured how fast these stars blinked, and by comparing their true brightness to how dim they appeared from Earth, he calculated their distance. The result was staggering, nearly 1 million light-years away, placing it far outside the Milky Way. Interestingly, his initial estimate was still too low. Later work by Walter Baade in the 1940s would double this distance after discovering there were two different types of Cepheid variables. But even with the initial calculation, Edwin Hubble proved conclusively that Andromeda was a separate, colossal galaxy. The universe wasn't just big, it was unimaginably vast, and our perception of reality had been shattered overnight. A new portrait emerges. Even after we knew Andromeda was a galaxy, getting a truly clear picture remained a monumental challenge. From our vantage point deep inside the Milky Way, it's like trying to map a forest while standing among the trees. Dust and stars get in the way. This is what led to one of the most ambitious projects in Hubble's history, the Panchromatic Hubble Andromeda Treasury, or FAT program. For years, a dedicated team led by principal investigator Julianne Dalkinton used the space telescope to systematically photograph a massive swath of our neighbor. The term panchromatic is key. It means they observed it in multiple wavelengths of light, from near ultraviolet to near infrared. This allowed them to see stars of different ages and temperatures: hot, young, blue stars, and cooler, older, red stars. The project spanned 411 individual telescope pointings, creating thousands of images that were then painstakingly stitched together. Finally, in January 2015, NASA released the result, the largest, sharpest image of Andromeda ever assembled. It's a breathtaking 1.5 billion pixel mosaic, revealing over 100 million individual stars. A treasure trove of data that provides the first truly comprehensive view of a large spiral galaxy's stellar populations. The Ring Mystery. With this unprecedented view, astronomers could finally dissect Andromeda's anatomy, and they immediately found bizarre features that defied easy explanation. One of the most puzzling discoveries, first hinted at by NASA's Spitzer Space Telescope in 2006, was the presence of distinct rings of dust and star formation. These weren't the graceful, continuous spiral arms you'd expect. A team of astronomers, including researcher Carl Gordon, used Spitzer's infrared cameras to pierce through the galaxy's obscuring dust, revealing a hidden inner ring. Farther out, Hubble saw a massive elliptical ring of hot, young blue stars. Another astronomer, David Bloch, famously described these features as being like ripples in a pond. What causes ripples? An impact. This was the first definitive clue that Andromeda's serene appearance was a facade, hiding a history of profound violence. The structures were too organized to be random, and their shape was inconsistent with the normal gravitational processes that form spiral arms. The galaxy hadn't just been peacefully spinning for billions of years, it had been punched hard, directly through its core, leaving behind scars that are still visible hundreds of millions of years later. Scars of ancient collisions. If Andromeda was punched, who threw the punch? The leading suspect was one of its small satellite galaxies, Messier 32. To test this theory, David Bloch and his colleagues ran sophisticated computer simulations in 2006. They modeled a scenario where a smaller galaxy plunged head-on through Andromeda's disk about 210 million years ago. As the intruder passed through, its gravity triggered a massive shockwave of gas and dust that expanded outwards, creating the rings of starburst activity we see today. The simulation almost perfectly reproduced the two major rings seen in the observations, but this was only one piece of the puzzle. Deeper investigations of Andromeda's faint outer halo by astronomers like Puragra Guhathakurta using the powerful Keck telescope in Hawaii revealed more subtle, ghostly streams of stars. A galaxy's halo is a vast spherical region of older stars and dark matter surrounding the main disk, and it's the perfect place to find the debris of past mergers. These stellar streams were undeniable evidence that Andromeda was a serial cannibal, building its immense size by consuming smaller galaxies over cosmic time. The giant southern stream. What other evidence of this violence is there? You can't see it clearly in visible light, but, deep meticulous observations of Andromeda's halo reveal a monstrous river of stars known as the giant southern stream. This colossal feature, spanning hundreds of thousands of light-years, is basically a trail of cosmic breadcrumbs left behind by another galactic meal. The astronomer Rodrigo Ibada and his team were among the first to map this structure back in 2001. They accomplished this by painstakingly measuring the velocities of thousands of individual stars in Andromeda's halo. They were looking for a group moving together, a telltale sign of a common origin, distinct from the random motions of the halo. What they found was the shredded corpse of a dwarf galaxy that Andromeda's immense gravity had ripped apart through a process called tidal stripping. As the smaller galaxy got too close, the gravitational pull on its near side was far stronger than on its far side, stretching it out into a long, thin stream of stars. The giant southern stream was, undeniable proof that Andromeda has been actively devouring its smaller neighbors for a very, very long time. M32, the smoking gun. The evidence now pointed to at least two major collisions, a recent one that created the rings, and a much older one that formed the giant southern stream. Could they be related? A groundbreaking study from 2018 put the spotlight back on the prime suspect, M32. Astronomers Richard de Souza proposed a unified theory. They suggested that the M32 we see today is merely the dense, stripped-down core of a much larger galaxy that collided with Andromeda 2 billion years ago. Their computer simulations showed that this lost galaxy, nicknamed M32P, would have been the third largest member of our local group. The evidence for M32 being a stripped core is compelling. It's incredibly dense, and its central black hole is far too massive for a galaxy of its current size. But it's just right for the massive galaxy it once was. This single, violent event neatly explains the rings, the stream, and even why a fifth of Andromeda's stars have a unique chemical signature. It's a compelling theory that paints a picture of Andromeda as a true cosmic predator that wears the remains of its victims. Satellites and secrets. While the M32P theory is compelling, the full story might be even more complex. Andromeda is the dominant galaxy in a gravitational empire, surrounded by dozens of smaller dwarf galaxies. We now know of at least 36 satellite galaxies orbiting it, each a potential witness to its violent past. Detailed studies of these small galaxies, like those conducted by astronomer Eric Bell, revealed a profound mystery. Many of these satellites are aligned in a vast, thin, co-rotating plane, almost like planets in a solar system. This is a huge problem for the standard lambda CDM model of cosmology, which predicts that satellite galaxies should be captured from all directions and orbit their host randomly. The strange alignment suggests they might share a common origin, perhaps being ripped from a single larger structure in a past cosmic event. The incredible resolution of the Hubble mosaic allows scientists to search for faint stellar trails connecting these satellites to Andromeda, hunting for more clues. Andromeda is not a static object but a dynamic, evolving ecosystem shaped by a constant dance of gravity and cannibalism, challenging our most fundamental theories of galaxy formation. Our galactic future. Here's where the story gets deeply personal. Andromeda isn't just a fascinating case study, it's our destiny. For decades, we've known it's hurtling towards our Milky Way at a blistering 110 kilometers per second. In 2012, a definitive analysis, led by Roland van der Marel of the Space Telescope Science Institute, used Hubble to track the subtle sideways motion of Andromeda's stars over several years. This was the final missing piece of the puzzle, confirming our fate. A head-on collision is set to occur in about 4.5 billion years. When it happens, the night sky will be spectacularly transformed as Andromeda fills our view. The two galaxies will then merge over hundreds of millions of years into a new, giant, elliptical galaxy. However, the ultra-precise PAT survey data has added a new twist. In a recent paper, astronomer Till Sawala used these new measurements to refine the models of the local group's mass. His team's work suggests the collision might not be a dead certainty, with some scenarios allowing for a glancing blow or a near miss. The future is still being debated, but one thing is certain: our galactic neighborhood is not static. From a nebulous smear to a cannibalistic giant on a collision course with our home, our understanding of Andromeda has been completely transformed. The 10-year Hubble project gave us a portrait of our neighbor that revealed a history of cosmic violence and an uncertain future. Scientists will be mining this incredible image for decades, uncovering more secrets hidden among its trillion stars. What other galactic ghosts will they find? Only time, and our relentless curiosity, will tell. The story of Andromeda is the story of our own cosmic origins and our ultimate fate, written in the stars for all of us to see. If you enjoyed this deep dive into our cosmic neighbor, don't forget to like, subscribe, and hit the bell icon so you never miss another journey into the cosmos. Thanks for watching Space Facts.